Hi, Michael Alvarez from Caltech and the Caltech MIT Voting Technology Project. And I'd like to welcome you to the next in our video series on resilient elections. Today, we're going to focus on the study of election forensics and specifically on some of the work that Ines Levin and myself have done, studying election forensics from a variety of different perspectives, and in particular using data from other nations. And I'd, on behalf of Paul Gronke from the EVIC at Reed, who's my co-host and collaborator in this series, I wanted to welcome Ines. I've known Ines for quite some time. She was a PhD student at Caltech. She is now on the faculty in the political science department at the University of California, Irvine. And her work is focused on the study of political behavior, turnout specifically. And she's also done a variety of different projects that focus on political science methodology, statistics, machine learning, and election forensics. So we welcome you, Ines. And the first question I wanted to just talk about is some of the work that you've done on election forensics. You've done a lot of research on election forensics. And would you really just kind of step back and kind of define what election forensics is and why you think it's important from your perspective as a researcher to study it, but also what election officials who are some of our viewers of this series can learn from the analysis of election forensics?
Well, first of all, Mike, thank you for having me. Okay, so election forensics refers to methods useful for detecting anomalies in election returns that may be indicative of election fraud or of voting irregularities. That is, irregularities that maybe were unintentional, right? So why is it important? Okay, so why is election forensics important? Okay, so we know that when people lose trust in the integrity of the process, this has consequences for their relationship with the system. Okay, so if people think that their votes won't be counted as intended, okay, then they might be discouraged from voting and they might turn out to vote less. Okay, so it is important for researchers to develop tools that can be used to sort of reassure voters about the accuracy of election outcomes. Okay, so that then voters will keep sort of trusting the system, okay, and that might have, say, maybe good in terms of people wanting to keep voting in future elections, okay? So it is also important for election officials to have tools at their disposal that they can use to sort of diagnose and fix problems in the administration of elections, okay? Problems leading to voting or registration irregularities, okay? So election forensics techniques, okay, are useful both for the purpose of kind of learning more about the nature of election outcomes, okay? If outcomes are fair in the sense that they are consistent with voters' intent, but they are also useful for election administrators in order to sort of identify locations where irregularities may have happened and then further explore and look into those precincts, for instance, to see whether something indeed happened. If there were problems with how the process was conducted in that location, problems with the machines, or whether if someone tried to sort of manipulate the process. Okay?
Mm-hmm. Well, and so there's a lot of these metrics and techniques that have been discussed in the research literature in particular. Back in 2001, the Voting Technology Project, built this particular metric that's been widely used, the residual vote. And it's, I consider it to be a kind of election forensic technique. But over the years, the work that you and others have done have been to devise a variety of different simple approaches to studying election forensics, but also much more sophisticated approaches using machine learning and AI kinds of technologies. Would you mind kind of walking through, kind of the various types from simple to complex of election forensic metrics that you've worked with, and then maybe we can talk a little bit about their relative merits.
Okay, so I will talk about over time how the methods that we've used have changed. And I think that the change that's seen in our own work mirrors the change that we've seen in election forensics more generally, okay? So when we first started working on election forensics, most of the tools that we used involved application of techniques for identifying anomalous electoral data. Okay, so two examples, for example, are distribution tests that were useful for identifying precincts with, for instance, unusually low or high turnout, where, for example, it also happened that the incumbent received an unusually high share of the vote. Okay. Another example are digit tests that are useful for identifying, for instance, regions of a country where vote counts looked suspicious in the sense that they looked as if they had been generated via some arbitrary process. For example, as if they had been fabricated by human beings rather than numbers being the product of some random process of the type that you would expect to see in a clean election. Okay? So we also employed other election forensic techniques, such as looking at the flow of votes between elections and examination of relationships between electoral variables, like, for example, looking at the relationship between turnout and vote share received by different candidates or parties. So the problem with the way in which we apply those techniques is that most of our analysis were entirely exploratory, okay? So our analysis did not yield estimates of the likelihood or amount of fraud, okay? And also no information about kind of the uncertainty associated with that, okay? With the perception, okay? That we got from the data about whether fraud happened or not. Okay? So all we could say is that we could say at that point in our research was that there were some locations that sort of looked suspicious because they deviated from most other locations in terms of key electoral variables. And those deviations were consistent with what you would expect to see in the event of certain types of fraud. Okay, but kind of but conclusions were, I would describe them as sort of vague, okay? Not precise in terms of we being able to say with some confidence, okay, with some level of confidence that fraud happened and that one particular amount of fraud most likely happened, okay? So some of the techniques that we used, for instance, relied mainly on the visualization of unusual patterns in data that look consistent, again, with what you would expect to see if there had been ballot box stuffing or vote stealing or vote destruction, okay? But we were just sort of visualizing the data and pointing out that, that some data points sort of looked suspicious. Okay, so more recently, part of the election forensics literature, including our work, has started adopting different techniques, in particular supervised learning techniques, that allow us to sort of overcome these problems that I mentioned before. Okay, so now we are able to quantify the amount of fraud and also get a sense of the uncertainty associated with those estimated quantities.
And this is coming about when you say supervised learning. This is you know, the fancy thing of machine and learning and AI, right? So what can you describe a little bit? I mean, think of it as, you know, we're talking to people who may not be familiar with machine learning or AI. They've heard the terminology. They think it's really fancy and it sounds very sophisticated. You know, what's the benefit of using these kinds of techniques from computer science? And again, I think you've kind of alluded to it just a little bit as to why it's a good tool in our election forensics toolkit, because it does provide the opportunity to perhaps differentiate different kinds of anomalies or potential fraud. It also allows us to say we're more or less certain about some of those estimates. But if you could talk a little bit more just about the mechanics of machine learning in this situation and how we use it and what kind of data is required and you know, how black boxy the estimation is, and you know, again, what the pros and cons of machine learning are for election forensics.
So machine learning refers to computation and methods for extracting useful information from data. So the term useful is vague, but for a good reason. Okay? So it depends on the application. Kind of what is useful, what constitutes useful information will depend on the task at hand. Okay? So in the context of election forensics, it refers to methods useful for detecting anomalies in election returns that may be indicative of voter fraud or of some other type of election irregularity. Okay? So in a way, election forensic researchers have always been doing machine learning. Okay? So even when we were doing the exploratory work that I described before, that was already machine learning. Okay? But initially we relied mostly on sort of unsupervised approaches. Okay? That are kind of exploratory in nature. For example, Some of the methods involved identifying sort of clusters of precincts, okay, that looked similar or homogeneous among themselves, okay, in terms of key electoral variables, but different from the rest, okay. Sometimes we identify those clusters sort of visually, sometimes using different types of statistical analysis. But those analyses were not guided or supervised. Okay, so after identifying the clusters, okay, or sets of precincts, it was up to us to label the clusters as clean or suspicious, okay, based on say typical values of electoral variables seen within those clusters. Okay. So more recently, okay, researchers, including us in our work, have increasingly been adopting supervised learning techniques, okay, that rely on training an algorithm to detect patterns in electoral data suggestive of fraud, okay, and then using the trained model to estimate the likelihood and amount of fraud in test data that was not used to train the model or algorithm. Okay? So in that sense, these supervised learning approaches sort of help us go beyond exploration, okay, and sort of be able to sort of quantify the amount of fraud and uncertainty associated with it. But they also have some machine learning algorithms. They have the problem that you described, that they may look at sort of black boxes, and the model or algorithm itself might not have sort of a straightforward interpretation. Okay, it may not be easy to sort of look at the model structure and be able to describe substantively under what conditions it is that it is more likely that you will observe a precinct, that you are going to observe fraud in a precinct rather than just a clean election. Okay? Just because the model structure may be kind of too complex. Okay. Yeah, so that's kind of the analysis tend to be sort of more complex, and maybe part of what we do may be more difficult to interpret than the sort of more than the simpler analysis that we did during those times when we focused exclusively on exploration.
Mm-hmm. Right, and a lot of these models, in particular, some of the ones that we've used in our work are what are called ensembles, where they're estimating many models, and they're essentially averaging them together in very complex ways, looking at lots of very finely granular interactions between lots of the different variables, and it makes it very difficult. I agree for interpretation. Now, the other trick here, though, with these kind of supervised learning approaches is finding the training data, right? And one of the things that I do really like about the sort of application of this machine learning framework in election forensics, but also in social science methodology more generally, is the differentiation of the training and the test data. The very kind of rigorous process that you go through to train the model on one set of data and then to apply it to another set. Now, in the election forensics world, we have two problems finding training data. One is simply just the lack of availability of data in many situations. The other is the possibility that the obvious sources of training data may be tainted. And so we've done a little research on this recently, and I was wondering if you wouldn't mind talking a little bit about what can a researcher do in a situation where they think that the potential training data they may use may be tainted with anomalies or even potentially with fraud.
Okay, so let me talk a bit about training data first. Okay, so training a machine learning algorithm for the purpose of detecting election fraud requires access to a data set containing examples of precincts or jurisdictions known to be either clean or tainted. The reason why I sometimes say precincts and sometimes jurisdictions is because researchers may work with data sets at varying levels of aggregation. We usually work with precinct level data, but other researchers might work with data that is kind of more aggregated, or even less aggregated if they're working, say, with data from a voting machine, and there may be many voting machines within each precinct. Okay? So just to state things more generally, I say precincts or jurisdictions. Okay? So again, training an algorithm requires having access to a data set containing examples of precincts or jurisdictions known to be either clean or tainted. Okay? So if such a data set is available, then the algorithm can learn what combinations of values taken by electoral variables, okay, are associated with the occurrence of fraud. Okay, so for example, an algorithm may notice that fraud happens more frequently. Okay, whenever incumbents receive unusually high shares of the vote. Okay, and also when you see turnout or other electoral variables displaying unusually low or high values. Okay. So the algorithm will learn about sort of combinations of values taken by electoral variables that are typically seen in the tainted examples, but not in the clean examples. Okay. So having access to training data is a necessary condition for you to be able to implement supervised learning approaches. Okay. So the problem is that in many cases where we would wish to use these type of techniques, we just don't have access to a data set containing clean and tainted examples, okay, that we can use, right, for training purposes. So, for example, the first thing that somebody may think about is just relying on data from a past election, okay, from a past comparable election. Okay, so if you look at an election happening not a long time ago, where electoral alternatives were pretty similar, and in conditions where you would describe electoral conditions in the country to be pretty much, say, similar as to the ones seen in the current election under investigation, then somebody may say, okay, so I will take the data from the past election, use those data as clean examples, and then basically see whether we see deviations from that for the data from the current election. Okay. So that could be used kind of, the data from the past election could be used as sort of as a starting point to develop for creating a sort of a training data set for the purpose of training a supervised learning algorithm. Okay. So a problem with that is that the data from the past election, from the previous election, may itself be tainted with fraud. So we cannot just naively use data from past elections for the purpose of generating training examples. Okay, so one solution that we propose in some of our recent research is to create synthetic training data. Okay, so this involves first generating hypothetical clean examples. Okay, the way we've done that is by processing data from a comparable past election, but not just using those data naively, but rather by adjusting those data for potential occurrence of fraud using model-based approaches. Okay, and then using the adjusted data, okay, as clean examples, okay, for the purpose of training the model. Then in a second step, of course, the training data set needs to contain both clean examples and tainted examples. So in the second step, we generate the synthetic tainted examples, and we do so by taking the synthetic clean data and altering it in ways that are consistent with what we would expect to see in the electoral variables in the event of, say, common types of fraud, okay, like ballot box stuffing, vote stealing, and so on. At this point, we try to inform our generation of synthetic data using, say, substantive information about the election under investigation. Okay, so we need to have a sense of which ones are the types of fraud that are more likely to happen, okay, in the event that election fraud happened in that election, and then based on that we can make decisions about kind of how to generate the synthetic tainted examples. Okay, then after generating these synthetic clean and tainted examples, we use the synthetic training data set to train the algorithm and then use it to detect fraud on real electoral data. Okay, so that's what we've done, and kind of the contribution of this method that we proposed for generating synthetic training data is that it makes it possible for researchers to use supervised learning techniques in many more situations than the ones than the type of applications that we've seen so far, say, done by other researchers. And then lastly, using the synthetic training data, okay, to train an algorithm and then use it to detect fraud on real electoral data.
So, you know, that this all sound, you know, it's very, very exciting. I think these applications of these kinds of techniques. But if let's just take a hypothetical for a second that, you know, it's we're close to the November election here in the U.S. And a state election official or someone from one of the larger states calls up and says, okay, Ines, we'd like for you to set up a process, you know, after election night, to try to monitor our state's election returns, our vote by mail ballot returns, our turnout statistics, you know, whatever metrics, you know, you decide. How would you go about setting up a project where you could apply these kind of techniques rapidly for an election official? And would it be a matter of being able to do it in you know, days or weeks, or how long do you think it would take for you to build a collaboration with an election official, say this fall, to apply these techniques in as close to real time as you could possibly imagine?
Okay, so here, Mike, I need to think about it because this
Sure, we're off script. I know. I think this is a good question. So, you know, just stop and think about it for a second.
Let me think about it a little, because I don't want to just off the top of my head say something.
I know, I took you off script. That's my bad.
Okay, so let me think about it. So my sense is that it should be, especially in situations where researchers are collaborating with election officials, it should be possible to develop and implement an approach such as the one that I described pretty fast, right? Because the sort of generating the synthetic training data requires substantive knowledge about the context in which the election is run, about if irregularities were to take place, which ones are the most likely classes of irregularities that we think may happen, okay? And election officials can help a great deal, right? In terms of providing that information to researchers that then they can use to specify the parameters for the purpose of generating the synthetic training data. So my sense is that it could be done within days. Mm-hmm. It all depends, right, on how many projects the researchers are working on. But if they are exclusively focusing on developing a model that can be used for detecting election irregularities, this can be done within.
It could be very fast. I mean, again, it seems very complicated and super sophisticated. But you know, the point I think to emphasize is I agree with you. I do think that if with a little bit of advanced warning, you know, these kinds of approaches could be, you know, pretty easily applied if there's a little bit of advanced warning, and you know, the researcher does have some of that kind of substantive knowledge where they can take the, you know, opportunity to work with an election official to get that kind of substantive knowledge so that they can build an appropriate training data set and be ready when the data starts to flow on election night. So so despite the apparent complexity, I do think that these kinds of techniques can be used very, very quickly, and I appreciate you confirming that. Now I want to kind of switch gears a little bit.
Something of that, but also, assuming that the researchers have experience in terms of implementing this type of methods, I feel like, say, if you've already done something like this for a different election, then you can basically take code that you wrote for analyzing data from past elections, even if those data were from different jurisdictions or even different countries, and say adapt the code such that you can use it to analyze, say, new electoral data. Okay, so you would only need to change a few assumptions, right? Just to make them consistent with the different nature of the election that you're currently focusing on, right? Now, of course, if researchers do not have this type of previous experience, then they might need to write code from scratch, okay? Or they might need to get access to code written by other researchers in the past, make sense of it, and then adapt it. And that may take longer, okay? So if the researchers already have past experience and they have software, right, that they've developed before and they can adapt to analyzing data, then it can be done very fast, I would say, within days.
Well, and also I think another way to think about that would be that if election officials are interested in doing this kind of work this fall, that if they got in touch with researchers in their area or people like yourself, in the next, in the coming weeks and months, you could actually, build the necessary code base using existing data from past elections, right? Mm-hmm. That you could pretty quickly apply to incoming data in November and do these kind of anomaly detection, fraud detection models pretty quickly in the immediate, days after the November election.
Yes, you can generate the synthetic training data set before the election happens.
Mm-hmm. And just be ready to go once the incoming data is available and you can ingest it, right? Mm-hmm. So let's change topics a little bit, because one of the things that I wanted to chat about was also you've been super successful at publishing a lot of work in this area of election science. I mean, it's in the academic world today, we hear lots of stories, and I know that you and I both have had our troubles with the peer review process and had to work really hard to get a lot of our work published. As someone who's really been very successful at this, and of course you're working at one of the major research universities in the world. What advice do you have for other scholars, in particular graduate students who are interested in working on elections or election science, or younger scholars who may just be starting out in a tenure track career? What advice do you have for them about publishing and getting their work out and accessible in the academic journals?
Okay, so before providing sort of a straight answer to that question, I want to summarize a little bit what has been my experience trying to publish this type of work. Okay, so I really like this question, but I will tell you from the outset that I don't know if I have a good recipe for, say, publishing election forensic work, because of all the areas of research that I worked on. So election forensics has been the one where I struggled the most, right, in terms of getting the work published. And I think that this happened for a number of reasons, okay? Because of a number of reasons that don't have only to do with the type of work, say, that we did, but also with the discipline and how the discipline used to receive this type of work. Okay, so I want to talk a little bit about sort of changes that we've seen, not just in the type of work that we've been doing and how we do it, but also in terms of the discipline and the value that it sees on election work. Okay. So the reasons why I think that, say, 10 years ago, it was difficult to publish election forensics research, I think are three. Okay. So first of all, analysis, as I said before, were initially mostly exploratory. Okay. And social science journals don't value exploratory work as much as research that is aimed at, for example, testing hypotheses. Okay. Second, a lot of the election forensics research published 10 years ago came out in computer science conferences. Sometimes researchers looked at, say, different type of audiences, okay? And so, can I start from the outset? Because actually, this is just an observation, it's not the second point. This was just an observation related to the first one. So, so I will start again with my response, okay? I'm sorry about that. But I really love this question. Okay, I just feel as if I rushed to talk and then it was like, but I really like it. So let me start again. Okay.
You're going to start at the top again.
Yeah, I will start at the top.
Okay.
For this one. Okay. So this is a great question. So I don't know if I have a good recipe for say publishing election forensic work, because of all the areas of research that I worked on, election forensics has been the one where I've struggled the most in terms of getting the work published. And I believe that this difficulty in terms of publishing election forensic research happened for a number of reasons. Okay, so first, because initially, most of the analysis that we did were exploratory, right, in nature. And social science journals don't value exploratory work as much as research aimed at, for example, testing hypotheses. Okay? So much of the research, of the election forensics research that was published, say, 10 years ago, came out in computer science conferences. Because computer scientists were appreciative of the computational methods themselves, and they saw the value in exploration. Okay? So more recently, a few things have happened that have made it easier to publish election forensics research. Okay? So first, the social sciences are starting to value exploratory work more than they did in the past. Okay? And I think this has a lot to do with the increasing popularity of computational methods, and in particular of kind of the usefulness of unsupervised learning approaches, right? That are kind of exploratory in nature, and that people have been using, say, in other areas, like not in election forensics, for many purposes, including, say, analyzing text and analyzing, say, massive data sets. So second, the election forensic researchers have started adopting, say, other techniques, including supervised learning approaches that allow testing hypotheses, okay, about the occurrence of fraud. So again, I believe that a lot of election forensics is still exploratory, and the journals are seeing more value in that. But then election forensic researchers have also been incorporating into their toolkit techniques that they can use to test hypotheses, okay? And therefore now they are able to write papers that look more like traditional social science papers, right? Where you state some hypothesis about what you think happened in an election, and then you test that hypothesis about the occurrence of fraud using some, say, supervised learning algorithm. Okay? And also election forensic researchers have gotten better, I think, in terms of writing for a general social science audience. But there are still some challenges, okay, in terms of getting election forensics research published, and that I think are associated with the fact that many of the techniques that we use rely on assumptions for the purpose of detecting anomalies or quantifying fraud. Okay? And these assumptions are sometimes hugely consequential for the results. Okay? So I think that journal editors and reviewers are aware of that. Okay? So kind of they know that results to a large extent depend or are tied to assumptions made by researchers. And they are sometimes hesitant about publishing work that claims, for example, that fraud and illegal activity happened based exclusively, right, on data analysis that are rooted on strong assumptions. Mm-hmm. Okay, so that said, here's my advice in terms of, given this, what researchers can do to get their work published. So first of all, don't apply your method in a vacuum. Okay, so become informed about the context in which the election occurred. Okay, and then use this substantive knowledge to specify models and algorithms that make sense for the election at hand, okay? Where the assumptions sound realistic, right? Methods that, for instance, look for types of fraud that are likely to have occurred given the electoral system, type of voting technology, and so on. Okay? I mean, it's not that you're assuming that fraud happened, but you are looking for types of fraud that may realistically have occurred in that election, okay? So if you're looking for types of fraud that are unrealistic given the characteristics of the system, then it makes sense that reviewers or editors would be hesitant about sort of publishing your work, okay? Because it might, substantively, it might not sound like a, say, reasonable method to use to detect fraud in that election, okay? Second, be transparent about your assumptions. Third, carry out sensitivity analysis, okay? Explaining how the estimated amount of fraud varies as you modify the assumption. Okay? Then also, fourth, report the uncertainty associated with your estimates. Okay? Don't just report point estimates about the occurrence of fraud. Okay? Also say something about how much estimation uncertainty there is, right, associated with those quantities. And then, to the extent possible, validate your results using auxiliary data, including qualitative information, such as information drawn from reports from election observers, allegations of fraud discussed in the media, and so on. Okay? So I think that if you take all of these steps, okay, and you make sort of a serious effort to say, specify reasonable assumptions, evaluate the robustness of the results to those assumptions, report uncertainty, validate results. If you take all of those steps, I feel it will be easier to get the work published, and for good reasons, right? You don't want work that doesn't take all of this seriously to actually go easily through the review process, right?
Well, you know, you started off by saying you didn't have a good recipe. And I have to tell you, Ines, that's probably one of the best recipes I've ever heard, not only for publishing research on election forensics, but generally for social scientists who are working in any kind of quantitative field. And in fact, I think we're just going to have to edit that nice little recipe that you just went through, and I think I'm going to you know, have certainly the PhD students at Caltech watch that little snip, because I think that's brilliant advice, and that I think that really demonstrates, you know, why you've been so successful in not only publishing in this area, but in many other areas. Just to close, you know, so this fall's going to be a very different election cycle here in the U.S. than we've ever seen before, because of, in particular, the uncertainty with the COVID pandemic, you know, and the recent Black Lives Matter protests. I think, you know, we all are facing a lot of uncertainty about what the November elections are going to be, how they're going to be conducted, how they're going to be administered, and literally kind of, you know, what may happen in that election. I think we're also very concerned that there might be concerns and questions about the integrity of that election in the fall, because it's likely to be very close. It's going to be probably very closely contested, and there could very well be, you know, all sorts of things that happen on election day, or the days before election, or even the days after. So how can these kinds of techniques, like you've talked about, these election forensics tools, how can they help us as academics better inform the public and election officials about the integrity of how the elections are administered this fall?
So the way I see election forensic techniques is that I don't see them as methods for, say, proving that fraud happened, or something kind of definitely an irregularity led to the wrong outcome in a certain location, or kind of, that's not the way I see them. I see them as information, okay, for election officials, okay, to a large extent, in the sense that that what we are doing is we're flagging locations that are potentially problematic. Okay? We don't know for sure whether something happened, okay, whether either something malignant or unintended happened in a polling place that led to, say, votes not being counted as intended, or to, say, registration problems in a certain area, or whatever. Kind of, all we're doing is just flagging. We're saying there's something potentially anomalous happening here. If there is some risk that an irregularity took place, it would be good for you to go and check, okay, and further explore what happened in this location. Okay. So I feel as if that will be the main role of election forensic tools in the upcoming election. So it can help election officials identify, say, areas of the country where either the registration or voting process happen under, say, less than ideal conditions, potentially. Okay? So just help them, because, say, election administrators have limited resources. Okay? So we cannot, say, have an election happen and then audit every single precinct, okay? And kind of, we're limited in the amount, in the extent to which we can monitor everything that happens, right? In all electoral locations throughout the country. So we need tools to kind of help us make more efficient use of resources, okay? To kind of figure out which ones are the locations that are potentially problematic, and then dedicate resources to figuring out what happened there, okay? So that's kind of my sense in terms of what the role of these methods could be in the upcoming.
Right. That's great. And so, Ines, I wanted to just thank you for spending some time today to talk about election forensics. And, you know, on behalf of, you know, myself and my colleague, Paul Gronke at Reed College and the EVIC, again, we just want to thank you for taking time with us today on our Resilient Election series.
Well, thank you for having me. I very much enjoyed sort of thinking about all of these questions.
Okay. Well, Jay, I think we're done. Thank you, Jay.